Sorry if that wasted some people's time. But the bigger thing that I want to talk about here is why did this happen? And this is actually important, because the hard thing about coding is not writing down the code, it's breaking through problems like this. So I fell into the same trap that many developers do. It was 12:30 at night, everything was working nicely. Oh man, I gotta get some tests out here. Let's write some tests, 3 tests together. I knew this end repetitions thing was a bit shady because there's this probabilistic aspect to it with the random numbers, but you know, I ran it, green bar showed up. I was pretty happy, I wanted to go to bed, right? So there's that issue. This issue is one that a lot of people have. Testing is not important. Just sort of throw it in because that's what developers do and I'm going to do it, you know. But it's super important and you should pay some attention to it. So that was my first flaw, that, you know, my own hubris again, my arrogance was that I know what I'm doing, and so tests aren't that important. I'm going to spend 5 minutes on it basically, right? Now the real part is that I was uneasy about the random aspect, but I pushed on, and there'll be many times programming when there's going to be some little voice in the back of your head going, I don't know what's going on here exactly, and you just sort of, again, you're short on time or something, and you push on. Don't do that. Listen to that little voice in your head, and be cautious about it. Investigate what's going on. So, one, listen to yourself. The other thing is that there wasn't a good way to write a test here. There's this, you call this, you know, what happens in this function? It generates some random array, and then it loops, and it makes a key. It adds up, counts, and then it averages it. So the real problem here is that this method is doing an awful lot of things. And methods should be small bite-sized chunks of activity that are easy to understand and, second, easy to test. So this test was telling me I had this awkward design because I couldn't make a test for it. It was too hard. There was too much hidden stuff. Like I couldn't get to this array and say, I want to use this array for testing. Instead, I had to say, give me a random array of size 10, but I don't know what that array looked like. I never get to see that array, right? And so basically, at one point, you know, I had this big chunk of code in main, and it was doing all sorts of things, and I said, let's make a method out of this. And I just cut and pasted this huge chunk of code from main into there, and it's just doing too many things. We need to break it up so that, one, it's easier to write, and two, it's easier to test. And the testing was really screaming that at me, but I was just sort of ignoring that issue, okay? So, you know, maybe you want to break it up into set up test data, count costs, compute averages, anyway, something somehow that gives you more access to the innards of those methods and make those methods do the one thing they're supposed to do. In my mind, what's the one thing it does? It tests a bunch of repetitions of this code. That's a good thing, but in reality, it was sort of doing multiple steps that all have their own complications. And so there was no good way to get access into this huge chunk of code and test it, because the only thing coming in was like how big this array was, and the only thing coming out was count, and because of the random aspect, I couldn't control those issues very well. So all I'm really trying to say is that testing, its basic purpose is to highlight issues with code logic, like does it compute what it's supposed to do. But testing can also point out flaws in code structure or design. And in this case, it was really pointing out that my structure was a little clunky, right? I should break it into more pieces. And the design of a program is often the hard part of programming. Like, where are the natural boundaries between one part of the computation and another part of the computation? It takes experience to do that. So it was, you know, foolish of me to ignore the problems that testing pointed out and just sort of push on just to get this thing out the door. It would have been better off breaking that method into a few other pieces. And the other lesson, of course, is that testing, you know, let's just throw some tests together, it requires its own careful effort and testing of its own, which seems a little, now we got a problem here, right? Like, what's going to test my test kind of thing. But the idea with unit testing is that the tests are small enough that you can actually kind of effectively hand inspect them and figure out what's going on. And again, I kind of ignored that issue a little bit. So again, I'm bringing this up just to say programming is hard, design of programs is hard. There are a lot of tools out there to help you realize when things are going a bit wrong, and you should listen to those tools and not sort of push on and just sort of do what you want to do to get the job done. For the fix, I already removed it from the zip file and the CPM file. Just remove that test. It's annoying me. I was trying to rewrite it again. I was going to get even more clever with, I don't know. I had all sorts of ideas, but the real fix in this thing is probably to rewrite the structure of the testing code and allow it to be tested, but I don't want to break it up at this point now that people have already been working on it. So just get rid of that if you have that code downloaded already. There's that. It's the final test in the search test.java file, and just nuke it. All right, and just keep that in mind. Testing is hard. Pay attention to it. So questions? You kind of follow what I'm saying here? At least the outcome. Kill that. Kill that method. Any other quick questions about it? Or, yeah.
That means we don't have to do the method we have to write for that, right? Also?
You have to write the method, yeah. There's still one test that works.
I haven't looked at the homework test, so I'm assuming that there's a method that goes with this test case.
There's a method that goes with that test, and you have to write it to make the program work.
Okay.
Yeah.
So if we haven't downloaded it yet, will it is it fixed or should we?
It's fixed. I've updated. As far as I understand, I've fixed it, the two places you can get it: the linked zip file and the CPM download.
What was wrong with it?
What was wrong with it? That it failed every once in a while, even though your code was right.
Yeah, because I got sometimes I got 1.3 and it would fail at that, but I got it to work.
Yes, I mean your code. So anyway, it was weird that it was randomly wrong, right?
Yeah.
So I could hit it 3 times and it was okay, and then the 4th time it would fail. So, anything else? Any other kind of general questions about the assignment? Big picture questions? Nothing? Okay. I do think the one part you have to think about is that the one that asks you to collect up end suggestions once you've found a matching phrase. The structure to this data, it's all sorted, right? Look at the file, think about how one could, given a phrase that matches here in the middle somewhere, and there's phrases above and below it, how do you gonna make sure you can get those that are there up to 7? So you gotta kind of look at that and think it through and draw some pictures on paper and work on that a little bit, okay? It's not like the one right way to do it. A lot of wrong ways to do it, but okay. Okay. So Java so far, we've been doing our public static methods, little problem solving, writing programs at work, do certain things, but unfortunately, what we've been learning so far is kind of a lot. All right? And when I say that, I mean that it's not the way Java is designed to be used. We have been learning sort of procedural programming. And in procedural programming, you have a big idea with main, and it calls a bunch of methods or functions in the slide, and those functions break up part of the problem. And maybe they call each other, maybe one function calls another function, and it's a certain way of decomposing complex problems into smaller parts that are codable. And it's a very common style of programming. And in fact, the reason we start off this way is that I think it helps teach ideas of breaking big problems into small problems. It helps you move on to the next step. And we get structure from these methods and abstraction, because once you've written some low-level method that gives you a substring of length n, then you can call it by name and not remember that it's doing certain things inside it, and so you can forget the details about it, and it allows you to make quicker progress on other problems. And you can control how information flows. We have parameters that accept information, and then return value says what the computation result is. And again, that's all a perfectly fine way of thinking about programming, and a very common way, but it's not exactly what Java is designed to handle. So we've been abusing Java a little bit with all these static methods, okay? So what's difficult about this style of procedural programming, and I think we're hopefully running into some of these issues as we're getting our complexity level up a little bit with the programs, and that is we have to understand the connection between the data that we're working on and what we think these these methods are doing for us. All right, so we haven't had anything exactly like this, but let's say I had some code moon launch, right? So this is some sort of computation thing to figure out, I don't know, something about rockets, I guess. And we have these parameters. So what does this thing represent? Crew count. The number of people in the capsule or something, and that's probably a good thing to know for, you know, oxygen levels and maybe weight and things like that. Double fuel, what is that?
Not a gas in liters or gallons, we don't know.
Not a gas or like rocket fuel, right? And you're saying in liters or gallons, or, you know, we don't know, right? So how are we going to know, for example, the kind of units that are associated with this? Where would you get that information?
Commenting.
Comments, basically. Yeah, comments, right? So hopefully there's some params tag that says fuel is, you know, volume of rocket stuff in whatever rockets use as units, you know, liters we'll say. Megaliters, I don't know, something like that, right? But the problem is there's no way to enforce that unit kind of thing on there, right? So people can pass in numbers, and they might be thinking they're passing in gallons, and we're expecting liters, and you weren't paying attention, and so that's going to cause trouble. Same thing with weight, you know, kilograms. And it's not just units, right, but even just sort of fundamental kinds of things. Come back, that's deciding whether this is a one-way trip for these poor astronauts or a round trip, I guess. And food, in food, I don't know, maybe that's like number of meals. Maybe it's like which one of these crews is going to be the food. I don't know. You know, it's hard to tell, right? You got to read the comments. So anyway, there's this sort of understanding that you have to use these methods, and there's nothing in the code that makes that happen. It's basically up to us as programmers to understand all those little details and make sure we're using this method correctly, right? And that's the hard thing about procedural programming. So in contrast, object-oriented programming still has methods and things, but we're going to combine data and these methods tightly together into objects. And those objects will then have an interface to the rest of the code that says what can happen to that data. And so to do object-oriented programming, we're going to make classes. We've already wrapped all our code in this class keyword that we haven't really been using in any sort of meaningful way, but now it's going to become very meaningful. And a class basically tells you how these objects are built. And then the programmer basically asks these objects to do certain computations or tasks. And we've seen examples of this, right? We've made stuff. What's an example of an object we use that has some data inside it, and we ask it to do computations? So we've already used object-oriented programming from a user point of view, but not at a developer point of view. So what's something we've already used that's an object that has data in it? String, yeah. What's another one? String's sort of weird because it's like halfway between like a primitive and
Scanner.
scanner, yeah. So you make a new scanner. We pass in some data that stays inside my scanner instance. And then we can ask it questions. All right? So as next, we're saying, is there a token? It's acting on that data that we passed into it. We don't have to give it some new data here, right? It's already inside this object. And so we're asking this object to do computations on the data it holds inside itself. So in procedural programming, you can kind of think of it as a flow. Data comes into a function or method, does some computation, comes out. In object-oriented programming, we have these objects, that's the gray box, that has data and functions that work on that data kind of tightly connected to each other. And when at some point you can ask it for some results and the data comes out, but it's not so much a flow through it as a storage together kind of thing. Now this is a little ridiculous maybe, but I kind of like to think of these objects again a little more anthropomorphically. So we have our friendly object, and you can talk to it and say, hey, object one, tell me the answer to this thing, and it, delightfully hands you the change data. So you can think of it in, again, as sort of a structural thing, combining these two things together. Or in a, programming is now a friendly, you have all these pets running around basically, and you ask them to do tricks for you. And that's the way I kind of like to think of it. So it's a different mindset, right? It's not like you're not just saying, compute this, compute this, compute this. Instead, you have things that you talk to, and they do computations for you. So here's some code showing these two different styles. In the sort of procedural way, we might have a bunch of data, name and address and age, and maybe another set of these things. And notice I'm kind of using numbers here to disambiguate between the two different styles. And then I call some method that uses that data to do some sort of prediction. Now, on the object-oriented sense, I'm going to be making an object, an instance of a class, a person class, that somehow is holding this data inside it. And again, in Java, we use the new keyword to say I want to make a new one of these objects. And I assign it to a variable that references that object. And I can make a second object. And then I'm going to call a method of that object to do the work. And notice again, there's no data coming in here. The data was stored inside the person as part of constructing, as part of building up this object. And so this always seems a little mysterious, like, what am I predicting? What am I working on? I'm working on the data held inside the instance that called this method here. Now, something else on this code that you may have noticed that should trouble you. Does anyone notice it?
Use state 2 in the predict.
Here, right, I'm sending in name 1, city 1, state 2, and age 1. Right? There's nothing that forces these sets of data to be consistently together, basically. Right? And if I were doing a bunch of cutting and pasting, like I had trouble with my unit tests, it's very easy to, change some of the numbers, but not change all the numbers or something like that. And again, there's nothing in the code here that says all these one numbers have to stick together. It's up to me as a programmer to track all those details and enforce that happening. That cannot happen over here because this P1 object only knows its own data. It doesn't know about P2 at all. And so these are forced to be together in some sense, and this method is forced to work only on the data it knows about for that particular person. All right, so it's a different way of thinking about it. It's nothing too terrible. It's pleasant, in fact. People like object-oriented programming, but you need to kind of start readjusting what's going on in your head when you start thinking about this stuff. Now, and we'll write some code here in a minute, but some big points in object-oriented programming are what are called encapsulation and abstraction. And an encapsulation is the idea that we're going to hide the data in the object. So we send it into the object, and then we don't really have to know exactly what's going on inside the object anymore. And we're going to control access through code methods that we write for that class that enforces the ability to only interact with that data in certain ways. In other words, we're not going to give people free reign to do whatever they want. They can't set my age to be negative or something like that, something that's very easy to do. Over here, I could very easily have some other code that says age 1 equals negative 1 million or something like that, right? And then I pass it into my medical prediction program, and it decides I'm either already dead or I'm going to live a million years, or who knows what. So there's no enforcement basically to check on sort of weird values for that data. When we hide it in the object, we can add additional code to kind of enforce certain ways of interacting with the data. And so that protects us from ourselves when we're programming, and it protects us from that intern we just hired who's going to be doing all sorts of terrible things to our code. They can't just get in there and start changing values, whatever they think they should do. So encapsulation basically hides the data that we're working on under a layer of sort of access, and we'll see how that works. Then abstraction is basically sort of what we already have with our methods. We want to hide the messy details and interact with objects in a more natural way. So you can imagine having a person object, and maybe it has a birthday method, right? And if you were coding, again, and you saw a description of that, you'd be like, all right, I kind of know that's supposed to add a year or something like that, or tell me how old this person is, or whatever it does. It's pretty obvious from the name and a little description of what's going on. Now that method, of course, can hide all sorts of details. Maybe it has some huge chunk of code that deals with people that were born on February 29th during a leap year and has to figure out, special cases for how old they are based on the fact that their birthday date only shows up once every 4 years, kind of thing. And so that, that complexity was written at some point, but hidden under this nice name called birthday. And that's the way we're going to interact with that data, not sort of thinking about all those messy details all the time. So objects can have super complicated things going on inside them, but if you give some well-named, well-defined methods to interact with that data, you as a programmer don't have to know exactly what's going on in there. For example, asNext, hides all sorts of things about what a token is, white space, return values, tabs, all kinds of white spaces, what happens if we're the end of the thing. It just kind of does what we want, right? It tells us whether there's a token available. There's an awful lot of work going into how that happens. But this name abstracts away the messy details. And object-oriented programming is very good about doing that kind of thing. Okay, so when you make a class, you have to first declare what data is available for that object, and then implement code to work on that data. The data inside there is called instance variables. Sometimes you see them called data members. Those different programming languages have different sort of names for this stuff, and they sort of blend together a little bit. I'll try to stick to the idea of instance variable, and we'll talk about what that means. And then we make instances of the class with a new, and assign them references to those to variables, and then can use them elsewhere. All right, so let's make a class. So Eclipse. All right. So this is the same as we've seen before. I have a package. I have a public class person. Before the classes were just sort of holders for all these little methods we're collecting, and now they're going to be defining objects, so the more full-fledged use of a class. And in here, can't even type, I'm going to have I'll just type this up first, a string name and a string city and a state and a private int age. Now these are kind of weird, right? There's variables floating around in this class, so they're not attached to a method. And we'll see how they're used in a minute. The other thing is that I've now used this private keyword. So Java is very big on what's called access control. And these public, private, and some other ones are protected, other things we'll talk about soon, describe how other code can access these things. So if you have a public class, it means that code in another file, in another class, can access this person. It knows about it. It's allowed to define person objects and stuff like that, okay? If it's private, for example, a private instance variable, that means other code outside the class cannot use this directly. So I could not have a person object, P1, for example, and say P1.name and get to this variable. I'm not allowed to access it outside the class. But any code inside the class can access these variables.
So if you would change private to public, then you would be allowed to use those variables outside of...
Yeah, I'll try to show an example of that pretty soon. We don't have another class here yet to do that. But and it's common to make your instance variables be private, which is enforcing that encapsulation concept. In other words, other code cannot dive into your object and touch these things directly. They can only do it in ways that you define through your methods. Okay? Now, down in main, for example, I might want to make a person object. And I'm going to say this is a new person. And if I do this, this is all legal code at this point. Let me run it, I think, make sure it's legal. Okay, it didn't do anything. What happens again when you hit run? It looks for a main and starts executing there. And here it says, I want a person reference, me, that references a new person. And what Java is going to do in this case, let's get this down. it's going to make a new object, and it's going to say it's an instance of person, and inside person, it provides storage for each of these instance variables. So there's going to be a, well, I'll just use there's going to be a name, and there's going to be a city, and there's going to be a state, and there's going to be an age. All right? And that has a place to store a string for that, and a string for that, and a string for that, and an age for that. Now, if I say I want to build it like I did here, I'm not passing any data into it. It's going to be what's called the default constructed object, and it puts in a reference to a null here, a reference to null here, a reference to null here, and a 0 here. So it will try to initialize these instance variables to their default settings without any further information. Okay? So we've made an object. It is an instance of the person class. It is an object of that person class. And we're going to assign me to reference this object, right? Remember, anytime you make an object, you're not storing the values directly in the variable. You're storing a reference to that object in the variable. So this is somewhere on the heap. This variable is on the stack. And this variable holds a reference to where this is located in memory. Okay? If I were to make another one, U, it would point to its own object. It has its own storage for each of those things. So its name is distinct from the me name. And its U's city is distinct from the me city, right? They have their own storage for each of those instance variables. There's a copy for each instance we make of that object. Okay? Questions on that so far? Can I get the idea? Yeah.
So the data in the class, like name, city, state, you said private means only the methods within that class, and public means methods without that class can also use it. But why don't you don't put either one of those in front of the data?
That's another form called module or package access, and we'll talk about these subtleties in a minute here. Or not a minute, maybe a couple of days.
So the person object recognizes all these variables without putting them in as the parameter?
So we're saying anytime you make an instance of a person, it has these internal variables stored, even if you don't give it particular data at this point.
So with your code you just wrote right now, it already knows what all those are?
Well, I said these are the instance variables. So and it doesn't have any values for them. They're all default values. So let's look at me for a second here. I'm going to print out me dot age, and if I run this, it's a 0, age 0. Okay. Now I'm allowed to do this direct access to this instance variable because this main is part of the person class. Okay. If I were somewhere else, I would not be allowed to do that because it's private. And by somewhere else, I mean like another file, a different class somewhere. Okay? So this is weird. We're using that dot notation like we've been using for, has next kind of thing. But instead of getting to a method that way, we're getting to an actual internal instance variable, right? So it's not something we call, it's an actual variable that we can access this way, right? So there's two different styles here we got to be cautious about.
So is the person object type related to the class name? Is that how you got that?
This defines the object type. And we really are making types here, just like int is a type, and scanner is a type, and string is a type. We're now making a person type, right? And that's very powerful that we're basically modifying the language to have types that help us compute things that we're interested in.
If we initialized our me person with just one single string, would it assume that that string is name, or is there just extra?
All right, so the question is, I showed you something that looked like this, right? How does that work? Well, we have to define code to say how to construct these objects when we want to give it specific data. And these are called constructors. And they have their own style, their own syntax. And typically you want them to be public because you'd never be able to make an object if it wasn't a public constructor, at least outside of your class. And so you have access control. Constructors do not return a value, so it's not like void or int or person or anything like that. You just give the name of the object you're trying to construct, and you now give parameters that provide the information that you want to use to construct the object. So I'm going to make a string name, string city, string state, int age. Try to have a bracket there. Go back. Now, I've done something a little funny here. I put these little underscores in front of the on the parameter name here. And there's all sorts of conflicting conventions about how you specify what's an instance variable and what you specify sort of what's coming into a method like this. Notice if I had name and name, they basically conflict here, right? There's a name for the parameter and a name for the instance variable, and so you don't want to have a conflict there. And we will talk more about different code styles for this. I don't really like all these funny underscores and stuff, but I just wanted to show something in that direction because a lot of people do it.
What about .this?
Let me talk about that in a little bit, yeah. So in here, I can say name equals name. Now what's going on here? This underscore name is a parameter to the constructor, right? So it's getting its value from when I call the constructor. This name here doesn't seem to be defined in any scope that is this method here, right? This constructor, like there's no string name anywhere in here. And that's because methods of a class also have the instance variables in their scope. So I can access from a method of the class any of these instance variables just by typing the name of that instance variable. So all of a sudden there's some weird scoping stuff going on where before we were pretty strict about, you know, only things that are defined in a scope persist in that scope and they go away. But now all of a sudden we have these instance variables that can be accessed inside a method of the class and it knows about it. Okay, so I think this is always a little bit mysterious, right? You got some big class somewhere and all of a sudden there's just some variable name popping up. They have no idea where it came from. When you see that, go up and look and see if you can find it as one of these things up here. Also notice Eclipse made that kind of blue for us, right? And so it's decided that instance variables are going to be blue. And so you can kind of tell just from the color of this thing, as opposed to just the black ones that the parameters are. All right, so this name is really this instance variable, and it really is that thing that's stored in the object. We have access to that. Now I can fill in all these. City equals city, state equals state, and age equals age. Now I'll say it's fairly common to see the mistake of people doing something like this, right? That's not going to help you. That's basically saying take this default valued instance variable, which would be 0 in this case, assign it to the parameter we passed into the person constructor, and when we leave scope, that change basically goes away because we just changed that parameter value and then we're done with the method and it doesn't persist anywhere. So don't do the old switcheroo on the assignment here, right? We're taking a known value, the value we passed in as a parameter, and assigning it to initialize properly this instance variable in the constructor. Now, I can pass in, all right, David, Salt Lake City, Utah, 21. Don't laugh. And if I now print out me age, prints out 21. All right, that 21 was passed in here. It was assigned to this parameter and used to initialize this age instance variable.
If you'd only passed in David and not any of the other
So the question is, what if I don't care about that other stuff for some reason? And I got to call this something else than me. It's going to say the constructor, person, that takes in a string is undefined. Right? There's nothing that matches these one parameter method. Now, what can I do about that? I can decide to what's called overload this constructor. So you're allowed to have methods that have the same name as long as their parameter lists are different. Okay, so I can have another method, same name person. And in this case, well, I can do whatever I want, really. I can either leave it be a default initialized age, or I can give it a value that's sort of specific, always in this case, right? In this case now, I can call a constructor with a single value. There is a method, a constructor method that has a single string for its parameter list, so it can figure out what to do with it. And I can use it to partway initialize my object. Let me say, typically the job of constructor is to do a good job initializing all the different instance variables to some meaningful values so that the object has some consistent state, some consistent definition. Okay?
If we create another constructor that just used a single string, but we called it city or whatever, would that
yeah, it can't. The compiler's not smart enough to let you disambiguate. Like,
because it is the same name.
it's just the type of that parameter that matters.
So there's one parameter and it's a string. We've already got one.
We've already got one like that. There's other tricks we can do at some point to kind of get around that, but for now, it's a restriction. See, it's complaining to me here. Duplicate method person string, right? We gave the variable a different name. Again, that name means nothing to Java. It's just like it just cares that a string gets passed into this thing.
Sorry, last thing on that. Age equals 100 if you did for like the me too down there, or I don't even know where we're at now, but the system out, would it do 100?
So if I did me too here,
Now I'm confused because it's age. I guess it's.
okay, let's
Now
run it. Okay, so me holds the value 21 because we constructed it with a 21. Me2, which has its own independent storage, right? All those name, state, city, ages are different places in memory. Was assigned to be 100 and prints out that 100. Okay. And again, this name David doesn't mean anything to it, right? It's just a string. So don't get fooled by the values held in these instance variables. Yeah.
If we didn't have our constructor, we initialized age to 100 up in our instance variables and then tried to call it, would it ever?
So, okay, Java lets you do some tricks with initializing values up here. I don't want to talk about that right now. Okay. But the main thing is the constructor creates values to be stored in the object, and again, you can have different constructors that have different behaviors, and sometimes you wanted to have some sort of generic way of building something or not, and this is called overloading. When you have a method with the same name, different parameter list, you're allowed to do that. Okay. Now let's add a little more complexity to this. I've tried to make my instance variables private. That basically says I don't want raw access to those variables because people are going to do bad things. Like, so for example, down here, instead of just printing out age, I can again say me age equals -100. And if I print it out, nothing is stopping that from happening. Again, if this was some other code in a different file, a different class, I would not be able to do that because it's private. Okay, so it would just prevent other people from messing with that. More typically, we want to provide access control through what are called setters, getters, sometimes mutators, and they're basically little methods that control how these things are accessed. So let me just quickly make a getter. So I'm going to make a public string get name. And in here, I'm going to return name. And then I'm going to make a, that's the getter, it gets a value. Getter gets a value. And then I'm going to make a setter that's going to change a value. And in this case, if I change a value, I'm not returning a value. I'm just doing something internally to the object. So this has a void return type. It doesn't compute an answer. And it's going to be called setName. And I'm going to take in a string name. And in here, I'm going to say name equals underscore name. So this is a setter. Now notice there's something different here. We have a public and then a return type. What's missing from this method? The static, right? We're using static all the time. Static methods cannot access the instance variables of that class. They can only do computations on what's passed into them as a parameter. Okay? If it's not, and the problem is right now, in our mind, static is like the default. In fact, this is the default to not have the word static. So you don't really say this is a not static method. You just say this is a method of the class. You can call it an instance method if you want. It's more common to then refer to the special case of static by saying it's a static method, okay? So you're going to want me to say this is a not static method, but I'm just going to say it's a method of the class. This method knows about whatever values are stored in the object when this method is called. So down here, I'm going to do a system out println name. And I'm going to call me.getName. When I run this, it says name David. The reason it got David was me also knows about its methods. And these are actually probably more references as well, but there's this getName. GetName uses the data stored in the instance variables for that particular object, for the me object, right? If this was the me2 or really the u1, it would use the value stored in that object. So in this case, notice I'm not passing any values into getName. It goes up here and says, hey me, what is your name? And me actually is David. So it gets that value stored in name and just returns it out of there, and that's all it does, right? So it's pretty simple. It just says, I'm going to give you this value stored inside. The difference is, notice, this is a public method, so other code can use it, whereas these variables are private, so they could not get to it directly. Okay? Yeah?
Instead of saying return name, if you, since you set name equal to underscore name, if you said return underscore name, is that error or no?
There's no underscore name in this scope right here. That only exists in the scope of this method here, and in the scope of this method here, and the scope of this method here. But it's not an instance variable, right? So it doesn't have the right scope. Here we can change the name. So if I pass in Fred, all of a sudden me would hold the value Fred because Fred is assigned to the name instance variable. It's not a new object. It's just changing the value stored here to be Fred. Okay. Now why do this? Let me just do one more quick thing. Let's do a setter for the age. So public void set age, int age. Here I can do some tricks. If underscore age is less than 0, then let's assign age equal to 0 instead. In other words, not let people assign negative values to age. Else, we'll set age equal to underscore age. So now, if I try to set the age of myself and say it should be negative 100, it will force it to stay in some sort of valid age range, like 0, by setting the 0 to age. I no longer have unfettered access to age. I can't do sort of crazy things here. So if I do me.set age, and I set in negative 100, and then I print out me age, Prints out 0. So I've now made my data a little more bulletproof by not allowing people to set age indiscriminately. They can only set age through this well-defined method that controls how people set the age for an object.
Can we have a constructor call that? So like, when
Yeah,
we're
in here,
initializing
right,
it,
in here actually I could have called set age, well not set age, I could just call set age here instead of doing this particular thing. So I could use that bulletproofing in other parts of my class. Kind of thing.
Just to clarify, so in main we use .age because it's a static method. Because it's disconnected, so we have to use .age instead of just saying age.
This is all inside the class, so it's all sort of public to me, so I can kind of do a little more than I should be able to do.
Yeah.
Next time we'll set up another class and show how access is restricted here. All right, so we'll be spending a lot of time talking about this. Don't worry about it. I wanted to give you a quick overview of what's going on, but it's a different way of thinking about where data is stored and how you interact with that data, and we need to get into that mindset.